Hello students, in the previous video, we saw the derivation part of BRESENHAM's circle drawing algorithm. In this video, I am going to discuss how to solve the circle drawing algorithm problem. In this algorithm, these three parts are very important. Using this formula, we will solve the circle drawing algorithm problem. We know the starting point of circle drawing algorithm is 0, r and circle having 8 equal segments or octet, and we are going to draw only one octet. So our target output looks like this. The problem may be asked like this. So draw the circle with the given radius value. Here the radius value is 6 units. Write the given value and find the initial decision parameter. The initial decision parameter formula is 1 minus r. So the result is minus 5. Then we draw the tabular column like this. The first column is k, that is number of steps. Second column is decision parameter. Third column is next possible coordinate value of x and y. And the remaining columns having the values multiplied by 2 for calculated next x and y coordinate values. Before going to start the calculation, I write the formula for better understanding purpose. And I write the starting coordinate value, that is 0, r. Here the radius is 6, so I write 0, 6. When k equal to 0, this becomes p0, that is p0 value is minus 5. If it is negative value, we have to follow this formula. So x coordinate value incremented into 1 and keep the same y coordinate value. So 0 becomes 1 and write the same 6 value. Then immediately multiply the x and y coordinate by 2. So we can get 2 and 12. Then we find the next decision parameter, in which we use the previous decision parameter, that is minus 5. So minus 5 plus 2, then plus 1. So we can get minus 2, and again we can get the negative value. So we have to increment the x coordinate value and keep the same y coordinate value. So the next possible coordinate values are 2, 6. And multiply by 2, we can get 2 into 2, 4, and 2 into 6, 12. Then find the next decision parameter. So minus 2 plus 4, then plus 1. We can get plus 3. Now we can get the positive value. So we have to use this formula. Here we should increment the x coordinate value, decrement 1 from y coordinate value. So the next possible coordinates are 3, 5. Then multiply by 2, we can get 6, 10. Then the next decision parameter, write the pk value, that is 3, plus 2 into xk plus 1, that is 6, plus 1, then minus 2 into yk plus 1. So now that value is 10. So the result is 0. So the next value is 0. This value also positive value. So we increment the x coordinate value 4 and decrement the y coordinate value. So 4, 4 is the next possible x and y coordinate value. And after multiplying, we can get 8, 8. Now both the values are equal. For each iteration, we should check whether the x is greater than y or not. Initially, x value is always 0 and y value is always the radius value. So x value is always lesser than the y value. But after calculating, x value is incremented, y values may be decremented. So at one stage, x may be equal to y or x greater than equal to y. So at that stage, we stop the calculation. So I stop the calculation and go to the last part. Last part is draw the calculated pixels. So create a rough graph that start from 0 to maximum radius value in both the x and y coordinates. And first draw the starting point value. Starting point value is 0, 6. So 0, 6. The next calculated pixel is 1, 6. So I draw the dot 1, 6. Then 2, 6. Then 3, 5. Then 4, 4. So this is the final graph. So your circle may be reside in anywhere, but we treat the origin of the circle as 0, 0 and draw this arc only. So in the problem, you can find only the coordinate value for the particular octet. You need not bother about the taking symmetry points and shifting into original position in the problem. So try this problem. Here the radius is 10 units. You can cross check your answer with this tabular column. And finally you can get this graph. Thank you.